So this video is going to cover the idea of potential energy. Now, potential energy at its core is the energy that an object can gain from being displaced from whatever you want to call its 0 point. Now, I think the easiest way to show what I mean by a 0 point and how potential energy relates to that is by going through a few examples. So let's hop right in. Let's take a scenario where you have an object and it's a certain distance, d, from the top of a building. That's the ground. So the easiest way to think about this problem is if we set the top of the building equal to our 0. Now, the formula governing potential energy of gravitation is PE, grav, is equal to mass times gravity times height. In this case, let's say this object has a mass of 5 kilograms, and d is 10 meters. So in this case, potential energy is going to be 5 kilograms times the gravitational constant of Earth times d, which is 10 meters. So 500. Now, there's another way to think about this, which is equally as valid, which is if I redraw the scenario here, and we have the object at a distance. If we think about the ground as 0 now, you can see our distance for potential energy is not just to the 0 as it is before, but rather it's this entire distance here. So in this case, let's say the building is an extra 40 meters. And so now if we want to calculate the potential energy of this object relative to the top of the building, we now have to actually do this twice. We have to calculate the potential energy of the object relative to the ground, since that's what we're defining as 0, minus the potential energy, if you will, of the object as it's resting on the top. So if we take our new numbers, this total height is going to be 50 meters, because it's 40 meters for the building plus the original 10 meters. So if we take our numbers again, we're going to have 5 times 10 times 50, or 2,500. But now from this, we have to subtract a certain amount, which is going to be, as I said before, the potential energy of the object as it's just resting on top of the building. So in that case, this is going to be our mass, 5, times our g again, 10, times 40 in this case, because we're looking for the potential energy at this height off the ground. And this is 2,000, and 2,500 minus 2,000 is once again 500. The same answer that we got up here. So as I said, the same scenario can be thought of in two different ways that are equally valid, where you have, in this case, the 0 is the top of the building, in this case 0 is the ground. But obviously, this is much easier to work with because you run the numbers once and you're done, versus over here where, even though it's not hard, in this case you have to run the numbers twice, and it just adds on extra work that you don't really need to do. So to wrap this video up, here's a problem that you can try for yourself. So imagine that there's a pendulum hanging from the ceiling, and it's a certain distance above the ground. And this distance is a function of time. So the distance is equal to 1 plus 2 cosine of 100t, where t is the time since the release of the object in seconds. Assume that the mass of the object is 5 kilograms. Now, find the first time such that the potential energy of the object is exactly equal to 60. And yes, assume that you are on Earth. So once you've done that, I think that about wraps up this video. So thanks for watching, and that's it.